So, good morning, students. Today our topic is Kruskal algorithm, which comes under minimum spanning tree. Before that, we want to know about a term called spanning tree. So, spanning tree is nothing but a subgraph of an undirected connected graph. So, the input is of connected graph, which may be undirected graph. Then, this minimum spanning tree is nothing but it is one kind of tree in which the sum of weight of the edges as minimum as possible. So the application for minimum spanning tree is to find the path in a map, or general example is water supply network and electric grid. In all the cases we are using the minimum spanning tree concept. Now we are going to see a Kruskal algorithm under minimum spanning tree. So Prim's algorithm and Kruskal algorithm comes under minimum spanning tree. Today's topic is a minimum spanning tree. So it is a famous greedy technique algorithm. It is also used for finding the minimum spanning tree of a given graph. So the input for this Kruskal algorithm is the graph. It must be of weighted graph and also connected graph and undirected graph. So for directed graph, Kruskal algorithm won't work. So it must be of undirected graph. So this is the implementation beyond this Kruskal algorithm. So first step is we have to sort all the edges from low weight to high weight. Then step 2, we have to take the edge with the lowest weight and use it to connect with the vertices of the graph. So while adding the edge, it creates a cycle. If it creates cycle, then we have to reject that edge and we have to go to the next least weight edge. The next step is keep adding edges until all the vertices are connected and a minimum spanning tree is obtained. These are the only three basic steps while using Kruskal algorithm. So we have some thumb rules to follow this. It is nothing but you have to simply draw all the vertices on a paper first. For example, we have 8 vertices given. Then 8 vertices should be drawn on a paper. Then connect these vertices using edges with minimum weight such that no cycle get formed. Here, no cycle should be formed as a only rule. So this is the algorithm for Kruskal. So Kruskal of graph G. First time A starting matrix is not equal to none. For each vertex, we, if it belongs to graph dot vertices, then we have to mix it. Then for each edge u comma v edge comma vertices it belongs to graph dot edge. It is ordered by increasing order by weight of u comma v. Then if find set of u is not equal to find set of here v is not v, then we have to add a is equal to a union of u comma v, that is union of u comma v. At last we have to return a. It is nothing but we have to add if the weight is minimum. For example, we have 4 vertices. If the weight is 3, here 2, there is 7. We should first take 2, then 3, then 7. If cycle forms, then we should remove it. So look at this example. Here we have 7 vertices, 1, 2, 3, 4, 5, 6 and 7. So our thumb rule is first we have to write all the vertices simply. We have to draw all the vertices in a paper. So we have to draw this. So we have 7 vertices, 1, 2, 3, 4, 5, 6, 7. Then we have to connect. First we have to write the minimum value. This minimum edge is 12. 4 to 3 we have 12. For example, it is 1, this is 2, this is 1, just write the number along. So we'll write as 1, 2, 3, 7, 4, 5 and 6. Now we'll connect. Okay. The minimum weight is here. The minimum weight is 1 to 6. We have 10. So just connect this 10. Then next minimum is 12. So 3 to 4 we have 12. So just connect this 3, 4, 12. So we have done with 10 and we have done with 12. The next minimum is 14. So 2 to 7 we have to connect as 14. Then consider next minimum is 16. So 2 to 3 is 16. We have to check whether the cycles formed or not. Till now no cycles are formed, so no problem. Then we have another node called 22. So 5 to 4 we have 22. The cycle formed, no, so no problem. Then next minimum is 24. If we draw 24 here, we'll get a cycle. So we should not add it here. And next minimum is, oh, we have a minimum value called 8. 7 to 4 we have 18. So we missed it. If we drawing 18 also, a cycle will form. So we should not add that also. Then we have 24. 6 to 5, 24. If we connect, we get cycle? No. So no problem. We can include this node. Then last one is of 28. If we add 28 here, we'll get cycle. So we should not add this. So see. So first step we have to just draw all the vertices. Then we should connect one by one. So first step 1 to 6 minimum is 10. Then 2 to 7, 14 is minimum. Then 3 to 4, 12. So till now we didn't get any cycles. So next step we are connecting next element is 16. So 2 to 3 we are connecting 16. No cycle form, so no problem. We can add it. Then 5 to 4 next minimum is 22. If we add 22, no cycle form. If we connect 7 and 5 or 7 and 4, a cycle will form. So we should not add this. So next is while connecting 6 and 5, we have 25. So no cycle form, so we can add. If we connect 1 and 2 also, we'll get cycle, so we should not add this also. At last, we have to find all the edges, that is minimum cost by adding all the edges, that is sum of all edges. So if we add, we get the answer. So the complexity analysis is the worst case time complexity of Kruskal algorithm is order of E log V or order of E log. It is nothing but edges into log of vertices. Same as we can write also as edges log of E. These edges are maintained as min heap, not max heap. It is maintained